Alright, we're going to continue talking about linear systems of equations. We've already discussed how to solve them graphically and by substitution. Now we're going to look at another method called the elimination method. And there are 4 things to do with this method. The first is to align the equations, which means get all the variables on one side in the same order. So if you've got x's and y's, go x's first, y's second, equals your constant. Once we've aligned the equations, we can, this next step is sometimes optional, we can multiply one or both equations by a number to result in a variable with the same coefficients. Then we subtract the equations to eliminate a variable, and then solve for that variable. And then lastly, we use substitution to solve for the other variable. So let's look at our first example, which in our note packet is example 9. We're going to have 3x plus y equal negative 25, and we're going to have negative 7x minus 6y equal 62. So one of the goals really of the elimination method is you want to have the same number in front of one variable, but you want them to also be opposites. So I look at this and I think if I multiplied the entire first equation by 6, I can achieve that, because then I would have a positive 6y in the first equation and a negative 6y in the second. So let's do that. If we multiply everything in the first equation by 6, we're going to get 18x plus 6y equals negative 150. And then we can just rewrite the second equation as it was originally. Negative 7x minus 6y equals 62. We're going to go down, add down with these. So if we combine 18x and negative 7x, we're going to be left with 11x. Our y terms are going to zero out. And then negative 150 plus 62 is going to give us negative 88. So we've got 11x equals negative 88. If we divide by 11, we're going to find that x is equal to negative 8. So we've done steps 1, 2, and 3. Now we're going to go on to step 4. We're going to take negative 8. And it doesn't really matter which one you plug it into. I'm going to put it in the first one, the original first one. I'm going to go 3 times negative 8 plus y equals negative 25. You can use the other equation. You'll end up getting the same answer for y. I just look at this one and I think it's going to have less work. 3 times negative 8 is negative 24 plus y equals negative 25. So if we add 24, we're going to get y equals negative 1. So our solution is going to be negative 8, negative 1. Now let's look at example 10. we're going to have 4x equals 5y plus 10, and we're going to have 8x plus 9y equals 58. So the first thing we need to do is align this equation, or align the equations. So I'm going to subtract 5y in the first one. We're going to get 4x minus 5y equals 10, and then we're going to bring back down 8x plus 9y equals 58. Now that my equations are aligned, I notice I can find an x value. If I multiply the entire top equation by 2, I can get 8 in front of my x, which is part of what we want to do on step 2. So we're going to have 8x minus 10y equals 20, and then we can just rewrite that second equation again. 8x plus 9y equals 58, but we want to subtract one of these equations, so I'm going to just change the sign of everything in the second equation. So I'm going to make it minus 8x minus 9y minus 58. Now if we go down with the adding, the x's cancel out. We're going to get negative 19y equals negative 38. If we divide by negative 19, we're going to get y equals 2. So now we're going to take that and we're going to plug it into one of the original equations. I'm going to go with the first one. You don't always have to go with the first one. So we're going to have 4x equals 5 times 2 plus 10. Well, 5 times 2 is 10. And 10 plus 10 is 20. So that means 20 is equal to 4 times x. If we divide by 4, we're going to get x is equal to 5. So our ordered pair is 5, 2. All right, let's look at example 11. We're going to have the system 8x minus 2y equals negative 32, and 3x minus 11y is equal to negative 53. And that 53 did not look good. Neither does my 32. Let me fix those along with that y right there. Okay, so we can choose to eliminate the x or the y. It doesn't matter. I'm going to go with the x. What I'm going to end up doing is I'm going to multiply the entire first equation by 3, and then I'm going to multiply the entire second equation by 8, because I know 3 and 8 both go, if I multiply them, they'll make the same number. So in the first equation, I multiply everything by 3. I'm going to get 24x minus 6y equals negative 96. And in my second equation, I'm going to get 24x minus 88y equals negative 424. And then I'm going to multiply everything, or just change the signs of the bottom equation. So make it negative 24x plus 88y plus 424. And then I'm going to add going down. My x's cancel out. I'm going to get 82y equals 328. And then I'm going to divide by 82. I'm just going to use my calculator to do that. And I'm going to get y is equal to 4. I'm going to take that and I'm going to put it into one of my original equations. I'm going to do the first one. You can do the second one if you want and see that you'll get the same answer. So if we go 8x minus 2 times 4 equals negative 32, we want to solve this for x. So we're going to have 8x minus 8 equals negative 32. If we add 8, we're going to get 8x equals negative 24. Divide by 8, we're going to get x is equal to negative 3. So our ordered pair is going to be negative 3, 4. And we're just about done with this elimination method, and we might be able to throw a couple applications in. So, example 12, the last elimination example. We're going to have the system 6y equals 9x plus 39 and negative 3x equals 13 minus 2y. So we're going to start by getting all the x's and y's on one side. So in my first equation, if I subtract 9x, I'm going to get negative 9x plus 6y equals 39. In my second equation, if I add 2y, I'm going to get negative 3x plus 2y equals 13. And I notice if I multiply everything in that second equation by 3, I can eliminate one of my variables. So I'm going to rewrite that first equation, negative 9x plus 6y equals 39. And then I can multiply everything by 3. We're going to get negative 9x plus 6y equals 39. Adding down, or subtracting down, we make the entire second equation change their signs. We're going to get 0 equals 0. Well, in this case, just like in the substitution method, if we get a true statement from this, we say we have infinite solutions. If we were to solve this and get 0 equals some other number, we would have said there's no solution. So that's how we use the elimination method. If we get x equals a number or y equals a number, we know we're going to get one solution. If we have one just like example 12 here, where we get 0 equals 0, we're going to have infinite solutions. And we didn't discuss one in this video, but like in example 6 from the last video, if we get a number equals another number, we have no solution. And I think we might have time to squeeze in one application example into this video, so let's do that. So we're going to look at example 13. Example 13 reads, Jasmine has 35 coins in her wallet. All of them are nickels and quarters. If the value of the coins is $4.35, how many nickels and how many quarters does she have? So I'm going to start by giving some variables. I'm going to let n equal the number of nickels, and I'm going to let q equal the number of quarters. Now, I have to set up a system of equations. What we know is that she has a total of 35 coins. So if we take the number of nickels plus the number of quarters, that has to equal 35. We also know that the total value is $4.35. So a nickel is 5 cents, so we're going to go 0.05 N plus a quarter is 25 cents, so 0.25 Q equals 4.35. Now you might have asked yourself, why did I put these as decimals? Well, if I would have made them whole numbers, I would have needed to make $4.35 a 435. Because that's in dollars, we want to write what part of a dollar are quarters and nickels. Now we can use the substitution or elimination method. I'm going to go with elimination. So I'm going to multiply the entire first equation. I'm going to eliminate my n's. I'm going to multiply everything in that first equation by 0.05. Now that's going to give me 0.05 N plus 0.05 Q equals positive 1.75. And then I'm going to just rewrite the second equation. 0.05 N plus 0.25 Q equals 4.35, and I'm going to actually change the signs this time of my top equation rather than the bottom one. So it's negative 0.05 N minus 0.05 Q equals negative 1.75. So we're eliminating our nickel term. That's gone. We've got 0.2 Q equals 2.6. 2.60. So if we divide by 0.2, we're going to find that the number of quarters is 13. And then we take that and we put it into that first equation. N plus 13 is going to have to be 35. If we subtract 13 on both sides, we're going to get N is equal to 22. So that means Jasmine has 13 quarters and 22 nickels. And we're going to actually leave that for this video, and we'll look at a couple more of the application examples in our next and last video.